In this video, we're going to look at a new concept called the antiderivative. So up to this point in our study of calculus, we have been concerned primarily with the following problem. Given a function, find its derivative. And this works well in a lot of applications of calculus. You know, we have a function, we want to find its derivative, and then we use that derivative to look at a bunch of concepts within that function, such as rate of change and concavity and optimization and so forth. But many applications in calculus involve the inverse question. So now let's look at the inverse problem. And the inverse problem is, given a derivative, find the original function. Okay, so, for example, let's say I told you that the derivative of a function is 4x cubed. What is f of x? Okay, so that's an interesting question. We're given the derivative, and so we have to think about, well, what was the original function that when I take the derivative gives me this f of x, f prime of x? And so if you think about it, you'd realize, well, let's say f of x was x to the fourth. And that would make sense. So the derivative of x to the fourth is 4x cubed. So if that were the derivative, then the original function would be x cubed. So this is what we call the antiderivative, or this process is called antidifferentiation. So let's go ahead and write that out. The definition of the antiderivative. Okay, so a function f of x is an antiderivative of the function little f of x if for every x in the domain of f of x, the following is true. F prime of x equals little f of x. All right, so going back to our example from the previous one we just did here, we had a little f of x equals 4x cubed. And so we came up with capital F of x equals x to the fourth. Now the neat thing about antidifferentiation, or finding the antiderivative, is there is a way to check. You can always check your antiderivative. All you just have to do is take f of x, capital F of x, which is x to the fourth, and take the derivative of it, which is 4x cubed. And if this equals what we started off with over here, then you did it correctly. So if you take an antiderivative and take the derivative of it, and you get the original, or what we had right here, then you're okay. So now that we've done this, we can say, therefore, capital F of x equals x to the fourth power is in antiderivative of little f of x. So x to the fourth is an antiderivative of little f of x. Now, of course, I highlighted that in antiderivative. I know that seems fairly subtle, but you notice that I did not say that this capital F of x equals x to the fourth is the antiderivative. And in this case, it's a very important distinction. So let's take a look at some things. Let's say I have f of x equals x to the fourth, and so we already showed that the derivative of that is 4x cubed. Well, let's try this one. Let's say we have f of x equals x to the fourth plus 27. What's the derivative of that? Well, f prime of x. Well, the derivative of x to the fourth is 4x cubed, and the derivative of 27 is, well, it's 0. So we end up with 4x cubed. And we can do this for another. Let's say we have f of x equals x to the fourth minus 1,375. And we take the derivative of that. The derivative of x to the fourth is 4x cubed, and the derivative of a negative 1,375 is 0. So notice that we have 3 examples of a function whose derivative is 4x cubed. And essentially, the only difference between these is that we have a constant that I've added or subtracted from it. And so if we think about it, all of these are correct, and we're not exactly certain which one is the actual antiderivative. And, if I ask this question, how many antiderivatives exist for f of x equals 4x cubed? And because I could add any constant, and there's an infinite number of constants that we could add or subtract, the answer is infinitely many. So we have infinitely many antiderivatives for this derivative of 4x cubed. All right, so obviously we're not going to sit there and write an infinite number of solutions, and so we've come up with a way in calculus to indicate this infinitely number of solutions. And to do that, we are going to add a constant c. So let's go ahead and write that out. To indicate an infinite number of answers we use a constant c with any antiderivative. Okay, so what ends up happening now is when we have f of x equals 4x cubed, then we can say capital F of x equals x to the fourth plus c. And so this would actually be our final answer with that antiderivative. Right. Now, of course, because I went through this whole thing talking about the difference between an antiderivative and the antiderivative, and I gave you a bunch of examples, one thing to note about that plus c is if you don't write down the plus c with your antiderivative, that is an incorrect answer. Now, of course, if it's worth 5 points, I'm not going to take off 5 points, but I will take off 1 or 2 points depending on the situation. And the only reason I'm warning you about that is because it's actually kind of frustrating that if on a test I ask you to find, I don't know, let's say 6 antiderivatives, and you forget to put plus c for every single one of them, next thing you know you've missed 6 points. That, in reality, that should be an easy 6 points, you know, putting the plus c. So just make sure that you add that plus c in there so that when, you know, you don't get that wrong. All right, so there's a good introduction to the antiderivative. All the antiderivative is if you're given the derivative, what was the original function? And the other thing is you have to remember that plus c.